Didn't see you there. I was just doing some radical physics. Now I know what you're thinking. Carl, physics isn't radical, but it is radical. I'm the coolest cat around. So let's get started.
We're going to do the most radical ollie possible. We're going to have to learn about some crazy forces. Let's go to the professor to learn more.
Oh, hey, Professor. Can you teach me about some radical physics?
Sure thing, Carl. First up, we have mass, a measurement of how much stuff is in you. The unit for mass is kilograms. Up next, velocity, the distance something moves each second. The units are meters per second.
Oh, Mama!
Acceleration, the rate at which something's velocity changes each second. Now we're getting to the fat physics. Forces, the general strength that something applies to another thing. The net force on an object may be measured by multiplying the mass of an object by its acceleration. It is measured in newtons. Say, Carl, how many newtons are on that board? Tension, the force a rope exerts on something to pull it. Weight, the force gravity exerts on you. Normal force, the force the ground exerts on you so you don't fall through it.
Wow, Professor, one-dimensional forces sure are boring. Do you have anything more radical? As a matter of fact, I do, Carl. To do the most radical ollie possible, we're going to have to learn about torque. Torcular.
The reason the same force will have different effects on an object at different distances from its center of rotation is torque. Torque is measured in newton meters. It can be found by multiplying the force an object exerts by the distance from the center of rotation.
Professor, that sounds complicated. Well, maybe a groovy example will help.
Okay, a 1 meter long skateboard with linear mass is balanced at its center. A 2 kilogram bottle of Crystal Pepsi is hung 0.2 meters from its center. Where should the 1 kilogram bottle of Crystal Pepsi be hung to balance the system? Wicked, you're a fast learner. We know that the left side of the skateboard has a torque of 4. Thus, the 1 kilogram bottle of Crystal Pepsi must be placed 0.4 meters from the center.
To do the most radical ollie possible, we're going to have to call our friend Newton Nathaniel and get some help. Wow, that sure was fast. Now that I've dialed up my internet, I can email Newton Nathaniel. He's on his way.
Whoa, Newton Nathaniel, that was fast! I'm always fast. Newton Nathaniel, can you help us do a radical ollie?
Sure, you're gonna need my ollie equation.
Ollie equation?
First, let's go over our variables. We have Fa, which is the popping force that you apply on the board to pop it up into the air. MP, which is the mass of the person. Ms, which is the mass of the skateboard. R, which is just the radius from the center of the board, which is half the length. Big M, which is the mass of the person plus the mass of the board. T, which is the time it takes to do the ollie. H, which is the height from the ground the board reaches. And alias, the variable we were using for height. Let's go over now the torque part of our equation. First, we write that the applied force's torque minus the weight of the skateboard's torque is equal to the moment of inertia times angular acceleration. Next, we define angular acceleration as angular velocity over time. We then define moment of inertia as mass of the skateboard times radius squared. Finally, we can use algebra to find angular velocity. Finally, let's go over the energy part of deriving our torque equation. We set gravitational potential energy equal to rotational kinetic energy. We then write out our equations for each, and then plug in the equation we found for angular velocity into the equation for rotational kinetic energy. Keeping in mind that mass for gravitational potential energy must be the mass of the skateboard plus mass of the person, we can then use algebra to simplify and find height. We can use this to then find our Ollie equation.
Thanks, Newton Nathaniel. Now we can finally do our ollies.